everyone, welcome to the Math Tablet. In this session we're looking at differentiation, in particular finding gradient at a particular point. So here's an example. What is the gradient of this function f of x equals 5x cubed minus 6 over x at the point 1, negative 1? Well, to find out the gradient at a particular point, the first thing we're going to do is to find out the gradient at any point. In other words, find out the gradient function or find the derivative. So with my function f of x, what I'm going to do is use index rule and write this as 5x cubed minus 6 times x to the power of negative 1, allowing me to find the derivative a little bit easier. So here f dash of x then, when I differentiate, I'm going to get 15x squared plus 6x to the power of negative 2. So that's actually the gradient function, and that is true for any value of x. So if it is true for any value of x, and if I want the gradient at a particular value of x, all I need to do is to sub in the value of x that I want. So here at the point 1, negative 1, the x coordinate is 1, isn't it? So I'm going to be subbing in x equals 1 to find out the gradient at that particular point. So f dash at 1 then will be equal to, let's see, 15 plus 6 giving me 21. Therefore the gradient is 21 at this point 1, negative 1. Now we can do this on the class pad as well, so let's pull up our class pad. Okay, let's go into 2D. What we're going to do first is to choose that icon that looks like d by dx. Okay, enter the variable x there. In our brackets we're going to enter the function itself, so 5x to the power of 3 minus 6 over x. Okay, now because I want the gradient at a particular point, at the end of that bracket I now tap option and then tap that straight vertical line there. Okay, that will allow me to sub in a particular x value. So in this case I want the gradient function worked out at x equals 1, and then if I press execute I get the value of 21, which is the gradient at that particular point. So we can do this on the class pad as well. Now the other type of example that we're going to have a look at here is where you're actually asked for what value will have a particular gradient. So let's say something like this. When does the function y equals x cubed minus 5x plus 6 have a gradient of 7? So notice this time the question is in reverse. We're told the gradient, but we don't know at which point or at which set of coordinates. Okay, so we start off with our original function y equals x cubed minus 5x plus 6, which means that dy dx must be 3x squared take 5. Now I'm trying to find out when dy dx is equal to 7. So instead of dy dx I now put 7 equals 3x squared minus 5, and I will be solving for x. So let's see, 12 would have to be equal to 3x squared, which means that x squared would have to be 4, giving me two answers: x equals negative 2 or x equals 2. Now let's see, when x equals negative 2, substituting back into the original function, y would have to be equal to 12, and when x is equal to 2, substituting into my original function, y would have to equal 4, which means that the function has a gradient of 7 at the points -2, 12 and 2, 4. I hope you have enjoyed this session of the Math Tablet.